section 14.5 part 2, we are modeling this. We're looking at this graph and we want to find what the best equation to use to model this would be. So we need to find A, B, H, and K. So for this graph, our maximum point is good. Our maximum is the highest y value 1. Our minimum is -3. Our lowest. So the amplitude is the distance from the middle to the highest or lowest. You can get that from subtracting max minus min over 2, which is just 2. So that's the amplitude, and the center K is at max plus min over 2, which is -1. So it might be helpful. Sometimes it's helpful to actually put a dotted line where the center of the wave is. So the center is at -1. So because the graph starts at the center, so we're going to model this with sine or cosine. Yes, we're going to model this with a sine curve, because then we don't have a horizontal shift, because it starts at the middle of the wave. The middle of the wave, right here, is where it starts, and that's the center. So we want to use sine. So H equals 0, so we don't have to do a horizontal shift. And then our period, we can tell from looking at it. Our period, you have to look at x. So it goes from, one way of looking at it is from high to low. It takes 1 to go from a half to 3/2 for the x value. That's 1 to go from high to low. Therefore, to go from low back to high, it's another 1. So the period is from this high point to this other high point, which is going to be 2. This distance is the period, which is 2. So therefore, B is 2 pi over 2, which is just pi. That goes in the equation. So our final equation is y equals A, which we found to be 2A, sine of B, which is pi x, and then there's no H, and then K is -1. That's the center, -1. So this model will give us, we could find, given any x, we could find y and vice versa for any problem. So we're going to finish with doing a story. For this. So last example is, we're going to model with a story. So example 3 is the story / word problem is about, we'll just write down the key information. So a physical therapist recommends an exercise for a patient recovering from shoulder surgery. So it's a problem about a physical therapist. The patient extends his arm and rotates in a circular motion. At the highest point, the arm is 65 inches from the floor. At the lowest, it's 40 inches from the floor as you rotate in the circular motion. The arm makes 2 revolutions per second. So picture a second going by and you make 2 full revolutions. And then we're going to write a model. So we're going to write a model. Write a model for the height above the ground, for height in inches. In inches, write a model for height of arm as a function of time, t, which is in seconds. If the arm is at highest point at time 0, at t equals 0. So the way we're going to kind of graph it a little bit just so that we can get the information we need using the previous techniques. So in the problem that I read, the highest point would be at, so this is your height in inches of the arm off the ground, height in inches. And the highest point was 65 and the lowest point was 40. And you are allowed to ignore this region, so you don't have to scale the rest. We know the highest and the lowest is 40, so we'll only use the graph within that region. You don't need to worry about it evenly scaling these 2 points. So there's a point on the graph then at the highest that's right here at time 0, and let's label our axes. This is time in seconds. And there's also a point where, two revolutions per second is key information. We're given 2 revolutions per second. So how long does it take to go from 65 down to 40 back up to 65? So we have a high, we have a low, and back to a high basically. But how do I label? Where are these places? If it's 2 revolutions per second. So what would I label? How long does it take to go from high back to high? Good. So yeah, so you want to label this 1/2. That would be probably the hardest part of the problem. It takes a half a second to make a complete revolution, since you do 2 revolutions per second. It would take a half a second to do 1 revolution. That would be probably the most challenging of the whole thing. Now we have a graph with all the key information we need, so we just break down max, min, and find all the information. So the maximum here is good. Max is 65. Min is, the lowest point is 40. The lowest point off the ground was 40 inches. And okay, so the amplitude is 65 minus 40 over 2, which is, that's going to give you 12.5. It's a decimal, that's not a problem. K is going to be, so we want to find K, which is where is the center of this? Where is it shifted? That's just the middle of 65 and 40. So 65 plus 40 over 2, which is 52.5. And then are we going to use a cosine or a sine curve to model this? Why cosine? Because it starts at the highest. So the easiest to model would be with cosine, although you could always translate between the two, but you would have to then shift. So you use cosine is the easiest way. The period equals what? How long does it take to go from the highest back up to the highest? 1/2. So therefore b is 2 pi over the period. B is 2 pi over the, which is 4 pi. Yes, good. 4 pi. H, we use cosine so that h is 0. We don't have a horizontal shift, and we're ready for our final answer, which therefore, and we could use this equation then to figure out any information we want. So at any particular time we could figure out the height of the arm above the ground. So y equals a, which was good, 12.5. Y equals a cosine of b, 4 pi, x minus h, but there's no h, so x is just fine. Oh, but we don't use x, we use t, right, for time. And plus, what's k? And that's because that's the middle of our wave. So there's the model that we could then use to find anything we want.